Hi guys, welcome to another Under the Hood of. Today we're going to be taking a look under the hood of VS Code auto formatters. So VS Code has become a staple for many developers' local environment. One of the reasons is the really powerful extensions which can run from within the IDE itself, from type checking to code auto formatting. So here we're going to be taking a look at an overview of VS Code and then dig into how the auto formatting works. The final task will be to build a small version of Prettier, also like Eslint fix, if you like, which can run as a VS Code extension. And the goal of this is to understand the mechanics at work inside this kind of extension and some of the key differences with other types of extensions. So the plan today, we're going to be looking at Electron, looking at VS Code extensions, and then building our own Prettier extension. So Electron. Under the hood of VS Code is the Electron library framework. It's a software framework which allows for the development of desktop GUI applications using web-based kind of technologies. It combines the Chromium rendering engine and the Node.js runtime. So it's very powerful and very useful. And it was actually recently added to the OpenJS Foundation. There are two types of processes inside of Electron. The first is the main process. Only one is run at any time, and its job is to handle all of the re-renderers. The second type is a renderer process. There are many running at once. They represent a page with a UI, and their job is to run code. At the bottom there, you can see a basic example of creating a new node process, a renderer. You see using the child process and running fork with the server file. A small note about messages in Electron. Messages are sent across processes via IPC, which is inter-process communication, and this enables the renderer-to-renderer communication, which kind of bypasses the main process, so very useful. And then lastly, it's worth mentioning the GUIs are actually Chromium web pages. Onto VS Code extensions. So VS Code has extensions which introduce lots of advanced functionality. As it's built with Electron, it must still conform to the Electron process rules. Within VS Code, all the extensions run in a single renderer process called the extension host process. The process name is shared process, and in the task manager, they're under this code helper renderer, if you look for it. There seem to be two main types of VS Code extensions from what I can see. One's where the extension host process does all the work, and the second type is where the extension host process runs a client whose job is to spawn a server renderer process, which will do most of the heavy lifting. The server communicates with the client. This is common for something called a language server, and it's worth noting that only the extension host process can update the GUI. So, I wanted to touch a bit on language servers. Language servers are background tasks spawned by an extension for a specific purpose. TypeScript and Eslint are both examples of extensions which run language servers for their compilers. This is so the server can do the majority of the processing in the background and only needs to relay messages, for example diagnostics, to the client. They are often configured to run on save, and this produces a more performant client, so it's not blocking all the time. In general, it seems pretty good practice to run linters under a language server. There are several really strong positives of using a language server, such as persistent memory and caching. The server never dies, so can maintain a cache and memory to perform faster compiles in future runs. So if it's already got many files or many objects already in memory, it means faster runs will be will save a lot of time because there's already data stored there. And then faster boot up times. The server is already running, so shrinking any kind of boot up waiting time that you might have to zero. And it's finally worth noting that VS Code actually comes with its own language server protocol, LSP, which makes the client-server communication easier. It's a JSON RPC standard between the development tool and the language server. For extensions which do not run a language server, a common term is kind of one and done. Examples of this are Prettier and Mocha when there's no watch process being run. It's where the extension or the compiler runs once and then ends until it's called into action again, perhaps via a file save. They can be less performant than language servers, as there's no data or information being persisted, and most have to run in its entirety each time. However, there's no complex communication required between server and client. This can add a lot of code complexity, managing that communication. And for something like Prettier, which reformats the entire file, it would require sending a huge amount of data between the client and the server. So doing it all on the main extension process in the long run might end up being more performant. So, our own Prettier extension. We're going to build a VSCode extension, which will be a stripped down version of Prettier. It will run for two different scenarios. Scenario 1 will respect that no arguments are given and not change anything. And scenario 2 will recognize the arguments, format them correctly, and update the code in our file to what you can see below. So scenario 2 on the right, there's the before and there's the after. So very straightforward, really slimmed down and much of the complexity removed from Prettier. So the extension setup. On the left, we're going to add the necessary code to the package JSON. This will tell VSCode the extension JavaScript can be found in under source extension. This will register our extension to run on activation, which is when it starts. You can see the activation events block. And then this will tell VSCode to title our extension under Sexify it inside the VSCode command palette. On the right, as well, is a simple launch file. This is so VSCode knows how to run our client, and it's under a hidden .vscode folder. So basic text replacement extension. So now we're going to build a basic text replacement extension. Inside the source extension.js file, we're going to be adding this, as you can see. So let's walk through what it's doing. Line 2, we register our extension under extension.sexify it. Sorry about the name. Line 6 grabs the current active editor. Line 9 grabs all the document text. Line 10 grabs the range details for the current selected text. This is actually because the replace function needs a range given. We can't just give it the whole document. And line 13 calls our processing and reprinting function, which returns the new code, and we'll get onto that on the next slide. And then finally, line 16 and 17 replaces the current selected range with our newly formatted code. So it's very simple. There are many kind of free open examples of this on the VS Code samples website, and this is just one of them. So the AST processing and reprinting function. Inside the same file, we're going to define some AST utilities first. Line 2 to 5 are simple character utilities. You can see the space, the indent, a line break, and a comma. Line 6 is a small function for an expression statement being like my function. Calling that's an expression. The statements object you can see from line 12 contains functions for each AST node type with knowledge of how to print them. It's going to turn AST back into JavaScript. It contains an expression statement and a call expression, which is what we need for our scenarios. The bulk of the processing is actually done on line 21 to 28, as you can see. So we grab the number of arguments in the function on line 21. If it's not greater than 0, the checker's on line 22, we return it as it is. Else, on line 23, we add a line break, and then we're going to process each argument, as you can see on line 26. If we look into the details of line 26, we add an indent, then the argument name. Then we check if it's the last argument, and if not, we add a comma followed by a line break. If it is the last argument, we just add a line break. Finally, on line 29, we return an array of all of these strings. On the right, you can see what our function would output. So you can see there's an array, and it's got the function, the brackets, a line break, the arguments, all with the correct comma and line breaks, and then the final closing bracket for the. It contains all the necessary code, including the updated formatting. So, checking it works. So, by running our extension in debugger mode, which is F5, we can open a file with our JavaScript in. And there's an example of this in the test repository under Files, which will come up in a second. We highlight the code, open the command palette, find and click our Sexify extension, and then you will see it convert our single line function into multi-line with correct indents, exactly like Prettier does. So, thanks so much for watching. I learned a huge amount about VS Code and auto formatters from this research, and I hope it was useful for you. You can find the repository for all of this code here, the craigtorb/rn Prettier, and then shameless plug time. You can check my site, craigtorb.dev, for all my other under the hood ofs. Thanks for watching, and check back for more coming soon.